Imagine cruising in this shiny new electric car, feeling like a planet saver every mile. But thousands of kilometers away in South America's bone-dry deserts, a once vibrant Flamingo Lagoon is shrinking day by day, just to keep that battery alive and humming.
Hold on, what? How on earth does my future EV battery hurt flamingos in some far-off desert?
Tonight, we're diving deep into the hidden water footprint of lithium, the magic metal powering your EV battery. We'll trace it from the vast Andean salt flats, where it's pulled from underground brines, all the way to the charger in your driveway. And we'll confront a tough question. Can electric vehicles truly be our climate hero if their production is quietly draining some of the driest, most fragile places on Earth?
I mean, yeah, I'm all in on EVs. They sound perfect for cutting emissions. But now, do I feel a little complicit in some water crisis halfway around the world? Please, tell me more. Break it down.
We're talking billions of liters vanishing into thin air from evaporation ponds every single year. Here's our journey. First, we head to the salt flats to see exactly how lithium gets pumped up from those ancient underground brines. Then, we zoom out to the exploding global EV boom, driving insane demand. Finally, we land on game-changing tech shifts that could slash this massive water cost overnight. Oh, and stick around to the end of this honest review episode on the hidden water cost of lithium. You'll discover why local communities in these deserts are now fighting so-called green lithium projects harder than they ever fought oil giants.
Fighting green tech? That sounds wild. Like locals versus the future? Count me in. I'm totally hooked. And you guys home, don't forget to like and subscribe to the channel. Done already? Cool. Let's dive right in. Okay, let's start with the story we all bought into. The super clean pitch. Swap out your dirty gas-guzzling tank for a sleek electric battery. Plug into an increasingly green power grid fueled by solar and wind, and just watch those nasty tailpipe emissions plummet to near zero. It's the dream, right? Drive guilt-free, save the planet one charge at a time.
Spot on. That's the glossy ad version. But here's the part those commercials never show. Every single battery begins its life amid square kilometers of those bright, unnatural blue and green evaporation pools, shimmering under the brutal sun in high-altitude deserts like Chile's infamous Atacama. These aren't just pretty pictures, they're water thieves in disguise.
Whoa, those pools do look kinda mesmerizing from above, almost like alien art. But I sense a big catch here. What's really going on beneath the surface?
The catch? Pumping out lithium-rich brine from deep underground, then spreading it thin in those massive ponds to evaporate slowly over 12 to 18 months. It guzzles up to 2 million liters of fresh water per ton of lithium produced. Most of it lost forever to the desert sky. And in regions where annual rainfall is a pathetic few millimeters, that's not some minor industrial input. It's direct competition with ancient wetlands, struggling farmers, and wildlife hanging on by razor-thin margins for generations. Let's hit the numbers hard. Traditional brine-based lithium production demands anywhere from 100 to 800 cubic meters of fresh water per ton of battery-grade lithium carbonate equivalent. But factor in the evaporation losses from those sprawling ponds, and you're looking at millions more liters per ton. Some estimates top 15 to 20 million liters total when you count processing and site ops. This isn't theoretical. Peer-reviewed studies confirm it across major operations in the lithium triangle.
Millions liters of water? Where drops are gold for locals? That's rough.
like a huge sponge in a dry spot, yanking survival water.
So are EVs stealing water we don't see?
Big question. Let's dig into it. Let's put faces to the fallout. Meet a quinoa farmer in northern Chile, standing amid his dry, cracked soil that used to yield hearty crops, feeding families for miles around. His irrigation wells, running lower each season. Just nearby, a cherished flamingo reserve, home to thousands of those stunning pink birds, now counts fewer visitors yearly, their saline lagoons receding as lithium ponds balloon outward.
So locals connect the dots plain as day. Evaporation ponds multiplying while their water reserve plummet 20 to 30 meters in a decade. The flamingo populations in key Atacama spots have dipped 10 to 12%, breeding grounds parched. It's a stark before and after locals live daily.
Yes, global warming amplifies the heat and thirst, but Lithium Op's relentless brine draw and freshwater injections turbocharge the drain, turning green extraction into a local nightmare.
Hang on a minute. EVs really do slash tailpipe emissions, and over their full lifetime, they're cleaner than gas guzzlers in most countries worldwide.
Absolutely true, no denying that win. But does that give today's water-guzzling mining model a free pass forever? Hard no. Fast forward. EV sales are skyrocketing, projected 25 million units globally by 2026 alone, tripling lithium demand and putting salt flats worldwide under siege. Scenario 1. Blindly scale the status quo, plastering more water-intensive ponds across vulnerable deserts from Chile to Australia. Recipe for conflict. Scenario 2. Pivot smart. Deploy direct lithium extraction, or DLE, which selectively strips lithium from brine in hours, not years, recycling over 90% of the water back to source with minimal evaporation waste. Or embrace emerging sodium-ion batteries for grid storage and entry-level EVs. They use abundant seawater salts, zero pressure on lithium hotspots.
Boom! No waste! Sign me up!
That's correct. Tests show huge cuts already. So, bottom line, is your EV personally draining the desert? Not directly from your garage, but the lithium fueling its battery? Absolutely can, depending on the chain. 3 key deciders shape the outcome: where that lithium is sourced, how it's extracted without waste, and how fast we pour billions into recycling plus alternative chemistries.
Nailed it. Source spot, smart method, invest in next gen. Makes total sense now.
You don't need to ditch your EV dreams. Instead, push hard for stricter global mining standards, back companies sourcing low-impact lithium, and keep your current ride longer so every battery racks up maximum green miles.
Your action matters. Like and share this video. Subscribe to our channel if this opened your eyes, and follow us on Instagram at thegreenblueprint_TGB.
See you next time. Stay green, stay healthy, stay informed.